How does quantum superposition work in the real world? Imagine flipping a coin that is both heads and tails at the same time until you look at it. That's kind of what quantum superposition is like. It's a strange idea from quantum physics where tiny particles can be in multiple states at once. Instead of being in one place or one condition, they exist in a blend of all possible states until someone measures or observes them. This is described by something called a wave function, which is like a mathematical recipe that combines all the possible outcomes into one. Think of it as a probability cloud spreading out over space, showing where the particle might be or what state it might be in. When you do measure the particle, the wave function collapses, and the particle chooses a specific state. A classic example of this is the double-slit experiment. When particles like electrons or photons are shot at a barrier with two tiny slits, they create an interference pattern on a screen behind. This pattern only appears if the particles go through both slits at once, interfering with themselves as waves do. It's as if each particle takes multiple paths at the same time, which is super weird but supported by experiments. When we look at where the particle hits, the superposition ends, and it appears in just one spot. This behavior isn't just for tiny particles. Scientists have shown that even large molecules made of thousands of atoms can be in superposition. They can be in two places at once and produce interference patterns, just like smaller particles. This blurs the line between the quantum world and the everyday world we see around us. It makes us rethink how objects behave at a fundamental level. The principle behind superposition comes from the Schrödinger equation, which explains how wave functions change over time. The wave function itself isn't something we can see directly, but its squared value tells us the chance of finding the particle in a certain place or state. Because of this, repeating experiments can give different results, all consistent with the idea that particles are in multiple states until observed. From a weird science view, superposition is one of the most bizarre parts of the universe. It suggests that at the smallest scales, reality isn't fixed until we look at it. Particles can be in many states at once, which defies common sense. This idea has inspired thought experiments like Schrödinger's cat, where a cat in a box is both alive and dead until someone opens the box. Today, superposition isn't just a curiosity. It's the foundation of new technologies like quantum computers, which use superposition to solve problems much faster than traditional computers. Quantum sensors and imaging tools also relying on superposition and interference to achieve incredible precision. So, even though it sounds strange, superposition is real, and it's opening doors to amazing new possibilities in science and technology.